Let's talk a bit more about termination and also about memory management. As mentioned earlier, apps are generally moved to the background when interrupted or when the user quits. But before the application receives the application will terminate message, it receives the application did enter background message. That means for applications you compile and run only under iOS 4.2 and new versions, you only have to do the saving of the state and other cleanup in the application did enter background method. Remember, the method has about 5 seconds to do what it needs to do in return. Any longer than that, and your app is terminated and purged from memory. And as I mentioned earlier, even if you develop your app using the newest SDK and for running on iOS 4.3, you must still be prepared for your app to be terminated. If memory becomes an issue, and it inevitably will become an issue if enough apps are in the background, the system might remove your app from memory to make more room. If it does remove your suspended app in the background, it does not give you any warning, much less notice. If your app is currently running in the background, the system does call the app will terminate method of the application delegate if it purges from memory. And that method is here. And so here you would again save as much data as you possibly could because you only have 5 seconds. So we've learned to launch the app, initialize, process events, respond to events, terminate, and then we can launch again, initialize, process, respond, terminate. Has a nice rhythm to it, doesn't it? Those are the 5 major stages of the application lifecycle. But life isn't simple, and neither is runtime. Your app will also have to come to terms with memory management. One of the main responsibilities of all good little apps is to deal with low memory. So the first line of defense is to understand how you as a programmer can help avoid getting into that state in the first place. In iOS, each program uses the virtual memory mechanism found in all modern operating systems. But virtual memory is limited to the amount of physical memory available. This is because iOS doesn't store changeable memory, such as object data, on the disk to free up space and then read it in later when it's needed. Instead, iOS tries to give the running app all the memory it needs, freeing memory pages that contain read-only content such as code, where all it has to do is load the originals back into memory when they're needed. Of course, this may be only a temporary fix if those resources are needed again a short time later. So if memory continues to be limited, the system may also send notifications to the running app, asking it to free additional memory. This is one of the critical events that all apps must respond to. When the system dispatches a low memory notification to your app, it's something you must pay attention to. If you don't, it's a reliable recipe for disaster. The UI Kit framework provides several ways of setting up your app so that you receive timely low memory notifications. Let's take a look at them, and you find them in mainviewcontroller.m. When the system dispatches a low memory notification to your app gets the did receive memory warning message. And that is what happens in the utility application template. The view controller releases the view. Another way of handling a memory warning is to register to receive the UI application did receive memory warning notification. Such notifications are sent to the notification center, where all notifications are centralized. An object that wants to get informed about this notification registers itself to the notification center by telling which notification it wants to get informed and which method should be invoked when the notification is raised. A model object could then release data structures or objects it owns that it doesn't need and then recreate them later. But this is really beyond the scope of our My World utility app. It just helps to know that there are several strategies to give different parts of your app a chance to free the memory it no longer needs. Not freeing enough memory will result in iOS sending your application the application will terminate message and shutting you down. For many apps, though, the best defense is a good offense, and you need to manage your memory effectively and eliminate any memory leaks in your code. One of the most important things to remember is that when you create an object, a window or a button for example, memory is allocated to hold that object's data. The more objects you create, the more memory you use, and the less is available for additional objects you might need. Obviously, it's important to make available, that is, deallocate the memory that an object was using when the object is no longer needed. This is called memory management. And here's a little background. Objective-C uses what's called reference counting to figure out when to release the memory allocated to an object. It's your responsibility as a programmer to keep the memory management system informed when an object is no longer needed. Let's see how this works by looking at My World App Delegate again. Here is the deallocate method. It deallocates the memory occupied by the receiver. In this case, we're using release to release the window and to release the main view controller before deallocating the superclass. Reference counting is a pretty simple concept. When you create the object, it's given a reference count of 1. As other objects use this object, they use methods to increase the reference count and to decrease it when they're done. When the reference count reaches 0, the object is no longer needed and the memory is deallocated. Any object you create using alloc or new, any method that contains copy, and any object you send a retain message to is yours. You own it. That means you're responsible for telling the memory management system when you no longer need the object and that its memory can now be used elsewhere. With any given block of code, the number of times you use new, copy, alloc, and retain should equal the number of times you use release and auto-release. You should think of memory management as consisting of pairs of messages. If you balance every alloc and every retain with a release, your object will eventually be freed when you're done with it. When you assign an instance variable using an accessor with a property attribute of retain, retain is automatically invoked. That is, you now own the object. You implement a dealloc method to release the instance variables you own. But you don't have to worry about objects created other ways, such as through convenience constructors or other accessor methods. In this particular example, window and main view controller were created in synthesized statements, here and here. Therefore, we need to be able to release them, and we do so here. And by the way, a direct correlation exists between the amount of free memory available and your application's performance. If the memory available to your app dwindles far enough, the system will be forced to terminate your app. To avoid such a fate, keep a few words of wisdom in mind. Number 1, minimize the amount of memory you use and make that a high priority of your implementation design. Number 2, be sure to use the memory management functions. And number 3, be sure to clean up after yourself, or the system will do it for you and it won't be a pretty picture.